Hi, I'm Callie,
And I'm Steven,
and this is OPTIC380A Lab 7 Michelson applications.
and our TA is Michaela May.
Recreating the setup from last week, we moved mirror 1 to 3 millimeters longer from the beam splitter than mirror 2. Then we used the tip tilt to find the circular fringes again. We then moved the micrometer counterclockwise 62 micrometers to count at least 50 fringes. While this is a green source, we know that it should be around 546 nanometers, so there must have been some kind of error from either our calibration factor from last week or from counting the fringes when the circles were converging from this week. Replacing the green source with the sodium source, we moved the micrometer until the fringes appeared darkest. Then doing the same procedure as before, we count at least 50 fringes and record readings of the micrometer.
When adjusting for the darkest fringes, what we are referring to is fringe contrast. So as the fringes get darker, we are moving closer and closer to an OPD of lambda over 2. As we approach an optical path distance of lambda over 2, the fringes get darker, and then as we move away from that, that's why they get lighter and go away almost.
The purpose of this next part is to measure the wavelength separation of the sodium doublet with the Michelson. We saw this in measuring from null to null, so when the fringes became light to dark to light again and then averaged.
Starting from one null, we went through 3 more nulls here to get an average value of distance between null spaces. And using that value in our delta lambda equation, we came out with a delta lambda of 0.516, which is a negative 14% error from the expected value of 0.6 nanometers.
In this part of the lab, we are using the Michelson interferometer again to measure the refractive index of gases. In this part, we will measure the refractive index of air. The index depends not only on temperature, but also the atmospheric pressure specifically in this room, as well as relative humidity and wavelength.
So using the slope that we just got, we made this plot of refractive index versus pressure. You can see that the refractive index doesn't change much, even though there's big changes in pressure. So then to calculate the refractive index of air in this lab, we calculated the pressure at 73.356 centimeters of mercury and plugged that into our equation and found out that this value was approximately 1.00015.